Okay, this is page 7 of the I/O notes, and we're on section 3, and we're going to talk about interrupts. And the text reference here is 8.2. So the idea with interrupts is that you let the peripheral device signal the processor when it needs servicing. So let the peripheral device signal when it needs service or to be serviced by the processor. So polling I/O is synchronous, like it's happening when your program decides that it's going to happen. Interrupts can happen at any time wherever you are in your program, so they're called asynchronous. So let's just draw a simple system diagram. Here's our processor. I'll throw in the memory, even though it doesn't matter for this example. And then I'm going to have two I/O devices here. So I/O device number 1 and I/O device number 2. So our typical bus lines, I'm going to leave a little bit of a gap, but our system bus usually consists of 3 sets of wires, and so that would be the control lines, address lines, and data lines, and collectively that's your system bus. So for the ARM, you're likely going to have 32 data lines or wires, 32 address lines, and the number of control signals will depend on the bus, but there will be things like write enable, read enable, stuff like that. And now we're going to add the interrupt request line. So I/O device number 1 will have a signal going to the processor. So this would be IRQ number 1, and I/O device 2 would have its own signal, IRQ number 2. So they can just assert that signal, and then when the processor sees that, it will stop executing your program and run a special function or subroutine that's dedicated to that interrupt request line. So let's just add the rest of the connections here. So the I/O device will also be connected to the system bus, the memory will, and the processor will. So what we've added there are IRQ lines. So IRQ stands for interrupt request, IRQ. And interrupt requests are one kind of exception that a processor can deal with. There's actually 3, so there are 3 exception types. And number 1 is the interrupt. This is a request from a peripheral device. Number 2 is a fault. So interrupts are external to the processor. Faults are internal to the processor. So it's a problem executing an instruction. So the kinds of problems that you could encounter might be divide by 0, with integer operations, if you divide by 0, you're not going to generate a fault. But if you have a floating point unit, which our processor, the Cortex-M3, doesn't, but if you did, you can set it up to interrupt the processor on a divide by 0. So divide by 0. Other things that can go wrong is you could try to address a part of your program could try to read a memory address, and there's nothing there. There's no memory that's mapped to that address. There's no I/O device. So what will happen is nothing responds on the bus. Eventually it will time out, and so the processor interface to the bus will generate a bus fault. Okay, and the last one is a trap. And these are machine instructions or software instructions that programs use to request operating system services. So if you have a full operating system and you want to print, for example, you don't invoke the print driver directly. You call a function like printf, and it will invoke a trap or a system call. So it's an instruction that requests an OS service. Other kinds of things they can be used for are things like passing data between processes, stuff like that. So on the ARM Cortex, we have the SVC, which stands for service call, and this is on ARM processors. Okay, so interrupts are external, and faults are internal, as are traps. And only one of them really indicates a problem, which is the fault. And sometimes the fault can be dealt with. For example, with virtual memory, if there's a page fault, it means that your program's tried to access a page that's currently swapped out to the hard disk. That's not really an error, but the operating system needs to intervene and load that page into memory for you. Okay, and just up at the top here, interrupts, I think I just want to add that these are asynchronous to your program.